This first problem is a binomial situation. So it's coming out of chapter 10.5. So we're selecting a total of 184 people, and they either do abuse prescription drugs or they don't. So it's an either yes or no, and that's what binomial situations are. So there's a 42% chance that yes, they do abuse. So we're trying to find the probability that 79 or less abuse it. So to use the traditional binomial method that we learned back earlier in the quarter, you would have to figure out the probability that 79, 78, and then do it again for 77, 76, 75, 74, all the way down to 0. So you would have to do 79 separate problems and calculate it using the binomial formula. So instead we use the method from 10.5 and we just get an approximation that's really close to the probability of 79 or less. And here's how we do it. So we're going to use the normal probabilities, which are all those probabilities that are in the chart. We're going to use them to approximate the probability of 79 or less. So to use that chart, we have to know the z-score for what we're approximating. And to know the z-score, you have to know mean and standard deviation. So to start a binomial problem like this, you have to figure out what the mean is. And the mean is just the number of times the trials run, and this time we're asking 184 people times the probability of success. So 184 times 0.42 gives us the average, or the mean is that 77.28 people have abused prescription drugs. And to find the standard deviation, we use this formula. So just plug the numbers in, multiply them, take the square root, and you get the standard deviation of 6.695. So now we can figure out the z-score for what we're trying to figure out. But when we use this approximation method, we're always going to adjust by 0.5 and makes our approximation better. So we're trying to find for 79 or less, and we're going to use the normal curve to approximate. And to make it more accurate, we actually jump up by half a step to 79.5. So we're going to find the probability that 79.5 or less are on have abused prescription drugs, and that going up by half makes us more accurate. And we go up by a half to 79.5 rather than down by a half, because we're 79.5 or less includes 79 or less, and that's what we were originally trying to find. If you had gone down by half to 78.5, that's down by half. Well, 78.5 or less leaves 79 out, so you don't want to make the half step that way. We do the half step up because 79.5 or less includes 79 or less. Okay, so that's the challenge of these binomial problems, is just setting this part up and getting the z-score for your adjusted 79.5. From here, it's just like 10.4 now, because we're just going to use that sheet of probabilities to get our answer. So for 79.5, we find the z-score, which means we subtract the mean, divide by the standard deviation, and we get that's the z-score. And so the probability that z is less than that, we just have to look 0.33 up directly in the chart, because the chart tells us less thans. So we get 0.6293. So that is our approximation, is that 0.6293 is the probability that 79 or less young adults abused prescription drugs in the last month. So about 62%. Let's see, the next problem. So for this one, we start off by noting there's 14 total people and we're selecting 7. So notice these are our only options. We could select either 0 Democrats, 1 Democrat and 6 Republicans, 2 Democrats, which would mean 5 Republicans, 3 Democrats, 4 Democrats, 5, 6, or 7. Those are your only options. So the problem's asking what's the probability that at least 1 Democrat is selected. So the long way, at least 1 would be any of these options. This is at least 1 Democrat. So the long way is to figure out all 7 of these separately, and you'd have to add them together. The short way is to figure out the only other option and then do 1 minus the probability of this option, and it will equal all this highlighted stuff. Because all of these together, including the 0, add up to 1. So those are all the options, so they have to add up to 100% because it's all the possible options. So if you just find the one option that isn't what we're looking for and do 1 minus that, it gives you everything else, and that's actually what we're looking for, is this everything else part. So what we're going to do is figure out the probability that 0 Democrats are selected and then do 1 minus that answer. So to get 0 Democrats selected, I wrote it down in words what you want to do here. The bottom part is the total number of ways to select 7 people. And then the top part is going to be the number of ways to select 0 Democrats times the number of ways to select 7 Republicans. Because if we have 0 Democrats, that means we have to have 7 Republicans. And so the total number of ways to select 7 people, there's 14 total people, and we're going to choose 7 of them. The number of ways to select 0 Democrats, there's 6 Democrats, so we're going to choose 0. And to get 7 Republicans, there's 8 Republicans, and we're going to choose 7. So you put those numbers in, and it comes out to this. So the chances to get 0 Democrats is 8 out of 3, 4, 3, 2. And you want to do 1 minus that answer, because again, we figured out the probability of this. And 1 minus that gives us everything else. And everything else is what we're actually looking for. And so 1 minus that fraction gives us this fraction. And I know on the pre-test you have to reduce that in a fraction form, but on the actual test I would just switch that straight to a decimal. 3424 divided by 3432 equals 0.9977. That's the probability you're looking for. Alright, this one is going to be pretty similar. There's 18 total people. 12 are selected now. And what's the probability of getting an equal number of Democrats and Republicans? Well, with 12 people, that'd be 6 Democrats, 6 Republicans. So again, the total number of ways to pick 12 people would be 18, we choose 12. The total number of ways to get 6 Democrats would be there's 8 Democrats, we choose 6. And multiply that by 10 Republicans, choosing 6. And get those numbers, and that's your probability. Alright, for this one, here's the houses in the neighborhood. Here's the mean, add them all up, divide by 6, 80,000. The median's the one in the middle, which looks like I did that wrong. These two are in the middle, so average those two and you get 89,000. Okay. So which one gives a better, more accurate value for his neighborhood and why? Well, the mean would actually fit in right here in the data. So it's actually on the low end. There are 1, 2, 3, 5 houses higher than the mean and only 1 below it. The median, on the other hand, would fit in right here, and there's 3 houses below it, 3 houses above it. So it's actually giving you a better picture of the actual homes in the neighborhood because it's right smack dab in the middle. And just looking at these numbers, most of them are closer to 89,000 as opposed to being close to 80,000. 80,000 again is on the low end, while 89,000 is right smack dab in the middle. So the median's better, And the mean's thrown off because there's one house that's really low and it's bringing down the average. Okay. So here's a frequency distribution. Find the median value of the quiz scores. So if we listed all these quiz scores out, there's 2 zeros, there's 3 ones, then there were 7 twos, 7 threes, 8 fours, and 3 fives. So one way to find the median would be to find the middle number on a list like this. You don't want to rely on this method though, because what if there were like 300 people in the class? There would be 300 numbers listed here, and it'd be really time consuming to find the middle that way. So this class actually had 2 plus 3 plus 7, 7, 8, 3, 30 quizzes. So there's 30 students in this class. We can find, if there's 30 numbers, what number is going to be in the middle. Well, 30 is even, so there's actually going to be 2 things in the middle. To find the middle, you divide it in half, and that gives you 15. So actually the 15th and 16th entries, the 15th and 16th quizzes are going to be the quizzes in the middle. So here's your method to find the middle again. Just for the sake of argument, if there were 31 people in this class and we divide it by 2, that gives us 15.5. Anytime it's an odd number, like 31, there's only one quiz in the middle. And when you divide by 2 to try to find the middle, you'll get a decimal, because we're dividing an odd number by 2. And you always have to round up. So here it'd be the 16th quiz is the one quiz in the middle. So if you get an odd number, there's just going to be one in the middle. Divide by 2 and round up. If you have an even number, there's always 2 quizzes, or 2 whatever, in the middle, 2 numbers in the middle. So divide by 2, and then that one and the next one are the ones in the middle. So that's how you find the middle. Now, how do we quickly find what the 15th and 16th quizzes are? Again, we don't want to have to list them out and count. We're going to use these numbers here to find them. So let's scroll down a little bit. So the second quiz is a 0, because remember there's 2 zeros. We'll add 3 to that, and we'd be at the 5th quiz, right? The 5th quiz is a 1, because we go 0, 0, and then there's 3 1, so the 5th quiz is a 1. The 5th quiz, someone scored a 1. Well, we can add 7 more to that and get the 12th quiz is a 2, because there's 7 total 2s. So after the 5th one, add 7 more, we're at the 12th quiz, and it's a 2. Add 7 more to that, and we get the 19th quiz is a 3. Alright, so we've gone past what we want now. We want the 15th and 16th. So notice the 12th quiz was a 2, right? 2 plus 3 plus 7. The 12th quiz was a 2. The very next quiz is a 3. So the 13th quiz is a 3, and that's all the way up through the next 7 quizzes. So 13th all the way up to the 19th are 3s. So the 15th and 16th fall within that range. So the 15th and 16th are both 3s. So they are both 3s. So to find the median, then you would average those two middle values. Well, if they're both 3s, the average, or the average of those two values is going to come out to 3. So the median value is 3. And if you looked at this list, you would find the ones in the middle are the 3s. I'll do this one on the next video.